So in this lecture, we're going to be going over how to complete Excel workbook 1-2-2B, frequency polygon, and I'm going to go ahead and share my screen. So right here, we have 1-2-2B, frequency polygons. And what we're going to do is we are going to make a frequency polygon for this data here, okay? And so first thing that we're going to do is we're going to highlight all of this. You can press Control-Shift down, and then just click Control-Shift over, highlight all this data, and you are going to make a pivot table. So insert pivot table. And we're going to do, so the data that you highlighted is going to show up right there. Then we're going to put it into an existing workbook. So click right there and click location right here and press OK. And we're going to use this pivot table for all 5 of these pivot tables. So I'm going to do Control-C, Control-V, or Command-V, and then once again, Command-C, Command-V, 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 and Command-V. And notice right up here, it says this pivot table is going to be over ideal time to exercise. This one's going to be over walking, jogging, cardio, and weightlifting. So we're going to make 5 different pivot tables. So this first one is going to be drag ideal time to exercise into rows and drag it into values, and we're going to do that twice, okay? And then we're dragging into values twice. Doing the same thing with walking, drag it into rows, and drag it into values twice. And right here, we are doing jogging into rows and jogging into columns twice, or sorry, into values twice. And then cardio into rows and values twice. Okay. And last, weightlifting into rows and values twice. Before we move on, I need you guys to look at something because there was a slight mistake in this data. If you go down to, should be 76, I believe, yes, there's a 2. It's technically not a mistake, but it's to make sure that everyone's on the same page with the data. Go ahead and change that 2 to a 3. You would normally never do that, but we're going to do that. And then come right over here to the far one for weightlifting, and we're going to right-click, and we're going to click refresh. So you click right-click on the weightlifting and click refresh, and it'll refresh the data to represent, to show that that has a 3. So what we're going to do right here is we've got ideal time to exercise, and this is the one that has, it should have had the greatest range, so on and so forth, which that's the one that you want to start with, the one with the greatest range, number of observations. And you notice, once again, just like with the previous lecture, these all start with sum. We don't want sum. We want count for all of these. So you can literally just spend a minute and you can do summarize values by count, summarize values by count, and we're just doing this over and over again because we don't want the sum, we want the count. And it's just a whole lot easier to do everything all at one time. And I know it's really annoying. And we're actually going to do one more thing right after this, summarize values by count and summarize values by count. Now this one right here, count of weightlifting, we actually want this to be the relative frequency. So we're going to do percent of grand total. So this tells you this is the percent of the grand total of how much each one of these classes represents. And this is the percent of grand total as well. Show values as percent of grand total, percent of grand total, and percent of grand total. There we go. Now, like I said, these are the classes. Okay. They're all, yeah, classes right there. And what we're going to do is we are going to determine the class interval that these all need to be broken up into. So we're going to use the 2 to the k is greater than n rule. So 2 raised to the k is greater than n. And in order to do that, we've got n, which is right down here. N is the number of observations that we're looking at. So a total of 99. K is the number of classes we're about to find out, and we're going to do 1, 2, 3, 4, 5, 6, 7. We're going to do equals 2 raised to the first. Okay, then we'll drag it down. This is 2 raised to the second, 2 raised to the third, 2 raised to the fourth, 2 raised to the fifth, so on and so forth. So the 2 raised to the k rule is greater than n is what is the first number of classes? So 2 raised to the what is greater than the number of observations that you have. 2 raised to the 7th is the first one. 2 raised to the 6th is only 64. 2 raised to the 7th is 128. So we're going to have 2 raised to the 7th. The next thing that we've got to do is we've got to find the interval, okay? In order to find the interval, you find the max. So max is 25. The minimum is 3. Okay, and so you've got the range is going to be equals 25 minus 3. And so that's 22. And in order to find the interval, you take the range and you divide it by the total number of classes. So we're going to do equals 22 divided by 3. Sorry, not divided by 3, divided by 7. And that gives you 3.14. But we don't want 3.14. 3.14, if we come over here, you can right click and you can do group and do it by 3.14. And we don't like this because these look really weird, okay? And we don't want it to look really weird. Instead, and you can also come up here to group. You can group selection. We're going to do it by 3.5, okay? And so this is still 7 classes, but now it's broken up by 3.5, starting at 3 and being grouped by 3.5. And so we're going to come right here and do Control C, put it right there. And then we're also going to Control C, put it right here. Oops, and then do this, Control C, and put it right here, okay? So this right here is the relative frequency. And then up here is the frequency table. Okay. Now what we're going to do is I'm going to just copy these columns because I'm going to fill these in just a little bit. But I'm going to make a frequency table and I'm going to make a relative frequency table for all of these. And the nice thing is you've already done all of this work over here to change this data on the back end. And so we're just going to do the same thing once again, because we're trying to compare these one another, apples to apples all the way across with the exact same classes. So you've got all these classes. These classes have to mirror that as well. So we're going to group and make sure that it starts at 3 and then it goes by 3.5. Okay, so this is the ideal time for somebody to go walking. Okay, this is the ideal time for somebody to go jogging. So there's 99 people, and of those 99 people, 46 said that they went jogging. And these were the times that they said that they went jogging at. So we're going to group, and starting at 3 by 3.5. Okay, do the same right here, group, starting at 3, grouping by 3.5. Okay, and then once again, group, starting at 3 and going by 3.5. Okay, and so now you've got all of these broken up exactly the way that they're supposed to. With all these classes, they are perfect all the way across. And we can take this information and put them into the frequency table and the relative frequency table. So I'm just going to copy this, walking, put it right here. And you can pause this and do it by yourself, but then you put jogging for frequency. Then you copy and paste the jogging relative frequency. Then you do the cardio frequency and the cardio relative frequency. Okay. And then you do the weightlifting frequency. Whoops. Weightlifting frequency. and weightlifting relative frequency. Whoops, I accidentally messed that up. Control C. Okay, we've got the relative frequency and the frequency. Now, normally you would make a histogram and you would just do insert histogram. And you do that by making a bar chart and changing the gap width to 0. And in the previous lecture, I go over that a little bit more. But this is the bar chart for ideal time to exercise. And then I can highlight this and do Control Shift, or sorry, just Control or Command, hold down Command. You can do the same thing. Insert, walking ideal time. Change the gap width to 0. And do it again. Command or Control, hold that down. Insert. And then let's change the gap width to 0 again. Now, the thing is, what if I want to compare the ideal time to exercise to ideal walking time to ideal jogging time to ideal cardio to ideal weightlifting? I can't put these all on top of each other, okay? And if I go like this and I do insert bar chart, it actually displays it as a bar chart, and it's very difficult to see that you're actually dealing with continuous data. It is continuous data, so because it's continuous data, it needs to be represented with no gaps in between each class. So we're going to use something different called a frequency polygon. So with a frequency polygon, we are going to highlight all of this information right here, and we're going to do insert frequency polygon right here. And so we've got a frequency polygon. And then you can change the title, ideal exercise time frequency. Okay. And so you see these are all the different ideal exercise times. And you got 3 to 6. And what this is 3 a.m. to 6:30 a.m., 6:30 a.m. to 10 a.m., 10 a.m. to 1:30 p.m., 1:30 p.m. to 4 o'clock p.m., 4 o'clock p.m. To 8:30 p.m., 8:30 p.m. up to midnight. And then this right here is after midnight, people wanting to exercise at 1 a.m. in the morning. Not for me, but that's your prerogative. And so that's the way that this is all organized, and then you can compare them. However, there's a slight problem. The reason why there's a problem is because you've got almost 100 observations of ideal exercise time, and then for almost everything else, there's very few. There's a lot less observations, and so when you have almost 100 observations in one and half that in the others, it would be better for you to use a relative frequency polygon. And so we're going to come right over here and we're going to do a relative frequency polygon. We're going to do insert. Whoops. Insert. And this right here is a relative frequency polygon. And you'll notice here, let's make it look really similar as far as the height and everything. But they're very similar, but the big difference between them is that all of these, they look a lot flatter because they have a lot less observations. Now you're seeing them better, a better picture of them in relation to the sample size, and you can see that ideal exercise time, overall 10 to 13.5. And 13.5 to 17 is a little bit higher for like the overall average of ideal exercise time. But then each sport differs, or each activity is slightly different. But in general, they're pretty similar. They're all peaking at around 13.5 and then decreasing from there. And so you have the relative frequency and the actual frequency. And so if I were to ask, okay, what is the only exercise time, or the only exercise where 6 a.m. to 6:30 a.m. to 10 is still less than 10%? Well, that's the ideal time to exercise for everyone. Less than 10% is 6:30 to 10. But all the rest of the individual ones are above that. And then if I were to say, what's the exercise that individuals do the most or is done the most by individuals after, midnight, the only one is weightlifting. And so you can see weightlifting right there. And if you're colorblind or anything to that effect, you can change these colors, by the way. Just click on it and you can come over here and you can change the color right here and be like, okay, give me black, and it can change it to black, and it'll change the bottom to black as well, so on and so forth. So you've got the relative frequency, you've got the actual frequency, and this basically allows you to put all that it is it's like multiple histograms. So if I were to do just this one right here, this it would actually match this perfectly. Ideal time to exercise, it would match this perfectly. Walking ideal, so you click on walking, would match this histogram perfectly. Jogging would match this histogram perfectly, so this gray one. So it's basically a way for you to well, actually, it would match these all perfectly because these are all based on frequency. This is based on relative frequency, but it would match those perfectly, so it allows you to basically stack them all on top of each other, and that's how you would make these frequency polygons and the relative frequency polygons. It's really beneficial when you are comparing multiple continuous variables that are all able to be on the same scale here. So when you're able to compare them all apples to apples, going all the way down, and you want to compare them to one another, the distribution of them to one another, you can use a frequency polygon.